Hello everyone, my name is Courtney Brown, and I'll be your host today for our webinar, Using PEM to Understand and Improve Performance in Postgres, the Postgres Tuning Wizard and Performance Diagnostics. I'm joined by Mark Linster, Ashesh Vashi, and Bruce Momjian. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for an hour. We expect the presentation to last most of the time today and will allot any extra time for Q&A. If we don't have time to address all your questions, we're going to follow up afterwards by posting the answers on the EDB website on the webinar page. And without further ado, here's Mark to kick us off.
All right, good. Thanks, Courtney. So this is part of a webinar series that we're doing about every 2 weeks. We had a little break in the middle when we went through Postgres Vision, which, by the way, is also online. There's lots of interesting presentations in there that you can consume at your own leisure. So today we're going to talk about PEM. In 2 weeks, we're going to look at the new and improved features in Postgres 13. And then in August, in the first August session, we're going to look at EDB Replicate, which is a new upcoming product that is built on Kafka and Zookeeper. Now, every other Monday, we also have Postgres Pulse, which is a live call-in discussion of Postgres experts that Bruce and others are leading. And Bruce, when is the next Postgres Pulse session?
We have our dry run tomorrow, so that means that Monday at 10 a.m. Eastern Time is our next session.
Okay, great. So yeah, just check out our website, dial in there. It's a live session, live Q&A, always very interesting discussions. Okay, so what we're going to do today is, we're going to start with an introduction to PEM, talk about PEM, the Postgres Enterprise Manager. We'll talk about performance monitoring and the things that are important to keep in mind there, database tuning, how the PEM tuning wizard works, and then how we use the wait states information in Postgres to create a performance diagnostics dashboard. But before we dive into that, Courtney's going to walk us through a quick poll that we'll use just to put everything that we're saying here into context. So Courtney, please.
Sure, so here's our poll. How do you monitor Postgres today? EDB Postgres Enterprise Manager, Prometheus and Grafana, Datadog, custom scripts, or other. So we're going to give you a moment to submit your answer. We have some people coming in now. About 40% have voted. Once we get a good amount, we'll close the poll, and then we'll show you all the results so we can discuss as we go through.
Yeah, there's certainly been a very interesting shift in the industry. I mean, Prometheus and Grafana are getting a lot of interest. They're more monitor-only solutions, so it'll be interesting to see what our audience is saying here.
So here are our results.
Okay, great. That's interesting. Yeah, we would have expected, to custom scripts is something that's being used a whole lot. I assume PG Badger is playing a role there too. And then I think the next time we do this, we need to dig deeper and figure out what is in the other category, because after all, that's almost a third of our responses. Okay, thank you very much. And let's turn this over now to Ashesh for the presentation. Ashesh?
Yep. Hey guys, I hope you can see my screen now.
Yes, we can see your screen. Yes.
Okay, let me just start this. So thank you, Mark. And so as Mark has already gone through the agenda, let's start with the introduction with PEM. So what is really PEM is PEM? So the name itself suggests that it is an enterprise manager for a Postgres, and it manages the database. It is a management system which is built to tackle the management and monitoring of a large number of database servers. PEM's architecture is architect such a way that it tackles the statistics information and the status of your monitoring database servers, and underneath operating system as well, regardless of the operating system platform. All aspect of the database can be carried through PEM, carried through PEM client web interface, where you can do you can create the data, create a database, create the database objects like table, schema. You can create the roles. You can start and shut down you can schedule the start and shut down the database server. You can do the configuration management. You can do the performance diagnostics. You can analyze the queries and everything, and obviously you can run the queries using the query editor. Apart from that, apart from the administration, PEMS gives you a way to monitor the database servers, and it uses the lightweight agent to connect to your database server and collect all the performance statistics and some other information which is required you to understand the performance of the database and status of the database. It gives you whether your database is available, for how long it is available, and how did it perform at particular point of time. So those kind of things we can do using PEM. Apart from that, PEM also allows you to schedule some jobs which will automate your automate your some of the scripts or something like that to be run on your monitoring host, so that so this automation process will reduce the administration burden on the database administrator. Okay, so what exactly PEM can do? So PEM really collects and stores performance statistics as I earlier stated, and apart from that, it also collects some of the information like how many tables are there, what are the bloats are there, table bloats are there, what is the size of the table, what is the size of individual database. All those kind of data statistics can be used to do all kind of operations on your to analyze your performance of database server, or you can do the capacity planning using that. And using that data, PEM allows you to okay. Unfortunately, I have a very low network. Okay, so that data will allow us to create a threshold, create a threshold values, alert threshold values for individual objects, and that will and when those values are violated, that threshold values are violated, alert is triggered from PEM itself. So okay, triggered, and user can get those alerts on a dashboard through UI, or they can get a SMTP email or SNMP traps. They can also get that alert on a Nagios system. So integration of other monitoring tools is also made easy in a PEM. We can also use the REST API to do that operation on using PEM. Apart from that, so PEM facilitates you to do the performance diagnostics using the explain plan analyzer in a query tool. That is a built-in in a query tool. Then you can analyze the performance of the queries through SQL profiler, and for analytical queries which is running for a very long time, you can utilize performance diagnostics to understand the if there any performance degrade is happening over the period of time. That can help you. So PEM facilitate those kind of facilities. As I mentioned, in the monitoring system, PEM has more than 200 plus built-in alerts. Okay, so what other thing that PEM can do is customization. You can customize your PEM as you want. So basically, you can define custom alert templates where how do you want to test your certain data, that you can define using the alert template. You can also define custom probes which will allow you to collect the certain kind of data. In PEM, we use the probe term to say that term for set of matrices which are related to each other. So you can define that at the runtime, and you can utilize that for collecting your own type of data. It is not just limited to the system. PEM allows you to define the data retention period of those probe data, so that you can actually configure for how long you require that data, and even you can also define how frequently you would like to fetch that data. So that also can be defined through PEM. So the customization is really the one of the striking feature of PEM, which allows you to do everything and customization. You can also define your own custom charts, where user-defined charts, where it draws the it can draw the line chart or table, generate a table graph based on the data collected by different probes, and you can utilize that chart or existing chart on a custom-made dashboard as well. So it's a very flexible architecture, to be honest. So moving to PEM architecture. So basically, PEM has three main components. That is a PEM server, which actually keeps all the configuration parameters and about your monitoring. So PEM server keeps your configuration about the monitoring targets. A monitoring target can be your operating system, your database server itself, or you can define that as a particular database that you can define. Those kind of things can be stored in your configuration. PEM server storage, which is a Postgres or Postgres Advanced ADB Postgres Advanced Server. PEM server also is responsible for performing certain administration functions, and it keeps the data which is collected by the agents, which I will be talking about. It keeps the current snapshot and the historical snapshot for a reason, and it maintain that data for a certain period of time based on the configurations. setups. It can also do the trend analysis and capacity planning. It generates the different dashboards and everything. That is the job of server. The second component is PEM agent, which is responsible for collecting the data or collecting the data from the database server and the operating system both. PEM agent is a very flexible. You can use that database to monitor. You can install that PEM agent on the actual machine or VM where your database server is installed. That will give you a benefit in terms of it also collects the operating system statistics to diagnose the problem a lot better. And also it is also be used by the tools like components like Tuning Wizard and Postgres Expert to give you a right advice about configuring tuning your database properly. And also PEM agent is also responsible for doing certain tasks or scheduled tasks on that particular machine where your database server is installed. It allows you to run the scheduled job on that particular machine. The third component for PEM is the web interface, where a user can use their browser to connect to the PEM server, and it can display the charts, dashboards, and allow to interact to manage and monitor your database server through that UI. And each and every component can be accessed through the web interface. So PEM supports role-based component management, means each and every component or each and every tool which PEM has can be restricted by a particular user. So if user administrator can restrict each user to access particular components or tools. If you do not want your particular user to access capacity manager or tuning wizard, you can actually take away certain permissions from those agents, and you can do that. PEM also supports team support feature. So team support feature is nothing but sharing a particular monitoring target between different users. So a user register a database server or agent, and then they can actually define whether the other users can see that object in the screen or not. So that way also PEM is very flexible. You can define what are the things that you want to do and what are the things that you want to share with the other users. Okay, so where do PEM really stands? That is, so PEMs, as I said, PEMs allows you to monitor and do the alerting and management and administration. So PEM stands in between both of those functionalities. You can also see that MongoDB Ops Manager or Cloud Manager, which is for MongoDB, it has a similar functionality which allows you to monitor and do the monitoring and alerting and management and administration of the database servers. And similarly, Elephant Shed has some of those kind of functionality. On the right side, you can use pgadmin or Questoad to do the management and administration activities. And similarly, if you want just the monitoring and alerting, you can use the Grafana or AWS CloudWatch or specifically AWS clouds, Amazon clouds. So yeah, so as I said, PEM stays in the center. It allows you to do both monitoring and alerting and management and administration. Okay. So how do PEM do the performance monitoring? So as I said, PEM can monitor can be operated at different level, and you can monitor the metrics for operating system, the database server, the instance itself, and some some of the database specific functionalities, like if you need a table information or table size or function statistics, that can be, you have to connect to the particular database to get those data, and to get the list of foreign keys, functions, indexes, sequence, tables, views, all those kind of we run at the schema level, so that the load will be a lot smaller. So for each monitoring target, like operating system, we have 10 probes, so that collects actually 47 matrices. So which of them you can see CPU usage, disk busy info, or IO analysis, memory usage, network statistics, operating system statistics. All those can be used for performance monitoring. It can give you an idea about whether if your database is not performing well, what could be the reason. You can actually let those operating system matrices to understand the effect on the performance of the database servers. Similarly, for each database servers, we can collect a lot. We do have a 27 probes, which in turn collects 196 matrices. So in that, some of the monitored data can be block session, which gives you what are the sessions were blocked at particular point of time, and that will give you idea about if some interlocking has happened, if some sessions are just waiting for some logs to be released. Those kind of information can be figured out through that probes. Apart from that, database size can be useful, because after certain grow of the database, performance can degrade depending on the disk and how did you structure your database. So that you can analyze through database size and database statistics. It also collects the log information at particular point of time, the number of prepaid statements, transactions, and server log configurations. It also collects the current PG settings information to give you a right to understand whether. Yep.
I think key here for our audience is that PEM comes to the table with a very large number of best practice configurations that are available for you, right? And I mean, we've been developing PEM now, Ashish, for how many years? 8 years? Is that about right? I think we've been working on this for 8 years. So, and it's used by lots of large companies, as Ashish was saying before, for very large collections of databases. So what we're seeing here is really the things that we believe that a Postgres operator
monitoring. Oh, I'm sorry.
That these are the things that we believe that a Postgres operator should be monitoring. So, and these come out of the box for you. You can write your own using scripts, right? But here, Ashish and his team have pre-built all of these outcomes that you can just leverage and alert on inspect on, etc. So there's a whole lot of stuff that's coming out of the box that makes monitoring and management of Postgres a lot easier.
Right, and it is not just limited to that. That you can also, if you're not satisfied with that that much information, you can always create your own custom probes that will allow you to monitor certain data that you believe is a right thing to monitor.
Correct. You could, for example, you could monitor whether Bruce is mentioned more often in a table than Mark, and then you make an alert because that's not the way it should be. So you could easily do things like that in PEM, and those are the capabilities that that make management and monitoring much easier. So you don't just have to accept what we give you, even though what we give you has been built on years of working with PEM and with customers. But if you say, well, I really want to monitor bloat on an hourly basis, that's okay. Many customers would just say, no, I want to compare bloat in tables on a daily basis, and that's good enough for me. But you might have a small table with extremely high update ratio, and you say, no, I need to keep a much closer eye on this thing, and you just look at it every hour, right? So all those capabilities are there for you.
Yeah, and even you can create your own probes just to application specific. You can say that, okay, in this table, how many times you have, what is the bill at particular point of time, or how many transactions happen, or how many in a billing system, how many transactions happen in your particular point of time. You can calculate those kind of data also, create those kind of data through PEM custom probes mechanism. So it is not just limited to performance monitoring, but it is also it just adds a capability to monitor your own applications.
Mm-hmm.
The next thing that comes into the next thing that comes into picture is database tuning. So PEM, so you can tune your database at instance level, or you can tune your workload or schema tuning. So in a instance level, you can specify particular. You can at the time of installation, you can define the operating system, what is the memory, depending on the usage, you can define how many cores of hardware you require, those kind of things that you can define. But what would be the parameters at which that database will really works well? So that's where some of the components of PEM comes into picture, and it will give you, it can give you advice, or it can does the job for you, just like Tuning Wizard. Tuning Wizard can give you information based on based on the available memory. It gives it will give you advice on a certain parameters like work memory, maintenance memory, mem work, or wall max wall size, minimum wall size. Those kind of parameters can be tuned using the Tuning Wizard. And you can utilize Postgres Expert for getting the advice about schema or security features, or when I say schema, if you don't have indexes for your indexes for a foreign key, let's say our table has a column which is referred by certain other table, and if that column does not have index, your performance may degrade over the period of time. So you may want to have the index for that table, for that column on the table. So those kind of information can be given by Postgres Expert. And so Postgres Expert works at both in instance level tuning and your work schema level tuning. the other thing is capacity manager, where you can actually identify when you can actually capacity manager can be used for seeing your projected data, what would be the size of your database after a certain period of time, to give you to do the capacity planning and everything. So that's where capacity planning can be useful for your instance tuning. In the schema tuning, you can utilize the Postgres expert, as I said. You can also utilize the explain plan analyzer in the built-in in the query tool, where you can actually run the query at the runtime and generate the explain plan, and that gives you analysis of how much time has been spent by individual explain plan nodes to give you and that analysis will help you improve the query itself. So sometimes that query works really well in your development environment, but over the period of time your query may not work that well in actual environment. At that point of time, SQL Profiler comes into picture. And SQL Profiler, basically you can create a trace, and it collects a lot of information, like how many IO has been happened during the, how many buffer had been read write, how many data has been read write, what are the miss hit, whether that data was available in the system on the memory or not, whether the system has to read the data from the data disk, and what is the plan that it has used. So SQL Profiler, you can relate to SQL PG statement and the auto explain. It is a mix of both. So you can utilize SQL Profiler. In fact, you can enable or disable SQL Profiler at any point of time. Then next comes with the perform diagnostics, which uses the wait events to do the analysis. It is mostly used for long running queries. So where some of the queries, long running queries, are taking a lot of time, that can be analyzed through performance. We'll see that in the demo. So I believe I have already covered the tuning wizard. I would like to go to the demo first, so we'll talk about that there. So the perform diagnostics, basically, as I said, it uses the wait events, information available in the Postgres 9.6 plus, and it utilizes the EDB wait sets extension created by EDB. It is at the moment available only for EPAS EDB Postgres Advanced Server 11 plus. And so basically what it does is it runs in the background as a background process, and it collects each session at regular interval, and collects the whether that each of the session, whether they were waiting or they were actually doing some work. Those kind of information you can actually collect by the wait sets every regular interval, and that will help you analyze the query execution over the period of time. Auto explain or PG statement just gives you, or SQL Profiler gives you actually the consolidated value, how much total IO were used, or how much buffer was read, or those kind of information. While wait sets actually collects the wait states at particular intervals, so it gives you idea about the whole query execution over the period of time. So, and that's the reason I have said that it is very useful when you to analyze your performance of your query, which is running for a very long period of time. So, yep, let me just move to.
Before we dive into the demo, just for those of you in the audience that are coming from Oracle, this is comparable to the Oracle vDollar views, because what we do is we have the wait state events, or all the events, and we collect that information over time. So as Ashesh will show you, you can go look back in time and say, what happened this morning at 7:30? Why was the database slow? Was there anything unusual happening, right? So that's a capability that in standard, that with most standard Postgres monitoring tools, you don't have. Postgres has the data in the event data, but it does not collect that data over time. So what we did here in PEM and an advanced server, we're collecting that data and then we're presenting that for analysis.
Yep. So I'm right now running Postgres Enterprise Manager 7.15. We have improved a lot UI of the performance diagnostics, which we are going to release on 22nd July. So if you can't find it right now, don't worry about that. I'll go through that. It will be available in the 7.15. So let's first start with the tuning wizard. So I have this PEM console where you need to go to management, tuning wizard. In the tuning wizard, basically tuning wizard depends on your available memory and the swap memory to calculate your parameters which affects the memory the most, and it gives you a suggestion based on your maximum number of connections and available memory on the system. And that's why it is necessary to have the operating system statistics to give you right advice for those parameters. So I can actually I can define the workload here. So basically, whether I want to use this machine for a dedicated database server, or is it my developer workstation? This is my developer workstation, or actually I'm using this database server along the side of HTTPD. So I will have to make some space for HTTPD as well. So at that point of time, you can actually specify mixed use, or you can also specify developer workstation, and you can also see the workload session where whether your queries will be used for OLTP kind of workload, or it is going to be used for data warehouse. So, or it is going to be mixed of that. So you can define the workload section from here. And next, you can actually see the parameters that is advised by tuning wizard. It gives you information on effective cache size, maintenance work map, max wall size, mean wall size. So this means this parameter is already tuned on the system. It does not require you to be tuned. Then it also gives you random page cost, shared buffers, and the wall buffers. And the last but not the least is work map. So this is again depending on the workload you have specified in the on the previous page. So, and PEM allows you to change that on the runtime, or it can generate a report for you. So if you want to do that operation, you want PEM to do that operation automated, then you can actually specify what time you want to schedule that changes, and you can actually define those changes. Or you can generate the report and share it with somebody, and you can somebody and give the recommendation to the operating system administration to do these changes by themselves. So this report only suggests the values which are that needs to be changed. Not all values are specified here. So you can see that all the database server which I have selected has needs some values to be changed, and so you can actually review the whole report, and you can share this report with the other users. And you can in fact download this report as well while you are generating. So that is the role of tuning wizard. So the next is I have installed my EDV weight sets on one of my production server where I'm running long running queries, which are so many long running queries. And if I want to analyze each and every query, so I need to go to tools, server, performance diagnostics. It will take a lot of time because it works on a VPN. So I'm just moving on to existing workload which are already open. So you can see that this is the section where it is showing the data for 1 hour at I started this around 2-3 hours. So it is the current time, and you can actually define for how long that data you want that data, and then you need to select that particular section where you see the spikes and everything. So spikes, and when you select, you can actually see that selected data here. So here 35% of the time for all the queries which ran between this period has spent 35% of time for utilizing the CPU. That means it was not waiting for other queries to run, or it is not waiting for other operations to be done at that point of time. It spent a lot of time locking the lightweight lock. So lightweight locks are nothing but a lock on a database structure which is in a shared buffer. So because I'm running a lot of queries, with long running queries at the same time, and which are hitting the same database objects, we can see a lot of lightweight locks here. And it also spent a lot of time on IO. It spent around 20% of the time on IO. That means it spent 20% of the time to read or write on the disk. You may want to concentrate on a particular wait event or particular wait event or CPU utilization. So you can actually deselect the legend here, and when you deselect, it will disappear from the graph, and you can see how many active sessions were running and how much time they have really spent. So you can see that a lot of time has been spent for the CPU, and a lot of sessions were running at the same time. So you can select and deselect particular sessions, and you need to select a particular sample time or a time where this sample has been taken. So I have selected this sample, and it will give me all the information so all the queries which ran at that particular point of time. So this query was running 5 times at this particular point of time. This query was running for 3 times. Out of 3 queries, 1 query was doing some operations and using happen. So you can click on the I to see the actual details of these queries. So when I click on one of this I can see the query dashboard. I have because this is logged out session, I have not clicked on that. So it will give you information about what is the internal query ID that has been, who was the user for which this has been run, on which database it was running, what was the sample time. Sample time is the time, is the same time where I have selected this one. So because I can have n number of queries running at the same time, so we don't give that, we give the sample time at that. And this gives me information like at this particular point of time, same query was running on 3 sessions, and you can actually select those 3 sessions from here and see the wait events information. So while running this query, 83% of the time has been spent utilizing the CPU. That means it was not waiting for too many long time. So, and that is a good thing. But only challenge is it may also happen that so many queries are running at the same time and you don't have enough CPU cores available to run, because Postgres uses the process-based architecture, and you can relate those things with the CPU. Similarly, you can see some other queries. I have opened some other queries which has spent a lot of time on a CPU and lightweight locks. That means same queries were using the same structure at point of time, and so you can actually see what are the weight sets were there. You can see what are the actual weight set, that is buffer IO here, and what is the type of wait event type. So that is a lightweight lock and buffer mapping, and that is also a lightweight lock, and that's the reason color is similar for those charts. And how much percentage of time has been spent for this wait events. And if you really want to see at what point of time which wait event was happened, you can actually go through this table and see. You can actually see this information at that particular sample time. Again, this sample time has been taken every 1 second. So that is quite possible that it may not have collected all the wait events, but this gives you a lot of idea about how much percentage of time has been spent by your system, by your queries to process and waiting for the things to happen, other process to happen. So again, here you can see the buffer IO, it has spent a 47%. We cannot do much about lightweight, but definitely for analysis, IO and CPU are, to be honest, a very important aspect. How much time it has spent. So here it has spent a lot, 20% of time reading the data file. Data file are nothing but the table files reading from the disk, and buffer file read is nothing but your shared buffer is read from the file, and writing the buffer file. So how much spent that much time has been spent on IO. So yep, so that's how you can actually utilize the performance statistics to understand how much time and how much time has been spent on actual doing the operation, and how much time it has spent on waiting for certain actions to happen. So that's how performance statistics can be very useful. So I have some of the other examples where you can see it was waiting for timeout. So I've explicitly put PG sleep to just give you idea how much time it has spent. So the normal query should not have that, but yeah, so it is just to give you idea that it has spent around it has spent 41% of time just waiting for timeout. A timeout event can be other as well, so it is not just PG slips. So yep. And again, the more graph you have, that means this query has taken a long time to execution. And you can relate your start time near to this one because that is the first sample has been taken, and this will give you the nearest time to your end execution end time. So this also gives you how much time has been taken by this whole query. It is a approx time because samples are taken every regular interval. It is not exactly at the start of the query execution. So yeah, I guess I have covered everything for the performance diagnostics. Hello. Mark?
We're here.
Yeah, so I believe, so shall we continue with this, or we should move to the question answers?
I'm liking the picture.
So as you can
Okay,
see,
so I can talk us briefly through this before we get to the questions, and we've been running a little long, so I'll be very, very quick about this. Just, some of the reasons why we're so confident about PEM and the things that we're monitoring in PEM is because this is what we've been doing for, many, many years. We've been in business now for 14, or
16.
we've been shipping product for 14 years and business for 16 years, right? So, we have good experience here, know what we're doing, and in Gartner's ratings here, they're clearly reflecting that, from an ability to execute and completeness of vision, we're actually the only open source relational database in the Magic Quadrant. So that's why we feel pretty confident about the experience that's encoded in PEM and the value that it brings to our customers. Let's move forward. But Bruce, you were going to say something.
No, we just.
Okay, let's go forward. Okay, so, and again, the fact that we work with thousands of customers, lots of Fortune 500, lots of Forbes 2000, basically means that, we know that PEM scales, just it has to scale with what our customers do with Postgres. And some of those customers are running several hundred instances of Postgres in their business, and they're all monitored with PEM from a single instance of PEM, right? Because otherwise that would sort of defeat the purpose if there was not a single pane of glass. So again, this kind of tells you why we feel very confident about the probes, for example, that Ashesh talked about before. Let's move forward. Okay. We're very active in the open source community, so we're not just commercializing Postgres. We're working very hard and very involved in Postgres. I mean, Bruce, obviously, as a member of the core team, together with Dave Page. Then there's a number of people who are committing code. If you use any Postgres RPMs today, whether they come from EDB or from PostgreSQL.org, people like Devram Gunduz are heavily involved in that. Shesh Vashi, our speaker today, and his colleague Akshay Joshi are committers in PG Admin. Others are contributors and committers to PG Admin. Others are contributors to PostgreSQL. So we don't just work on the commercial side with customers and with Gartners. We're heavily invested in moving Postgres and the adjacent communities forward. Let's go forward, please. Okay, so, and we bring, I mean, obviously we work with Postgres, but then we know from our experience that the best database without the right tools, without the right contributions, without the right support, without the right services, well, it's just a piece of software, right? It doesn't get to be a business solution yet. We believe all of these things need to come together to actually create value for our customers. So enough talk about this. Let's get down to questions. Courtney, what do you have for us?
Sure, yeah, we have few minutes for questions before we conclude. So let's start with one that actually came through a couple of times. Can I use PEM or the tuning wizard with PostgreSQL open source, or does it only support EDB Postgres Advanced Server?
PEM and the tuning wizard work with both PostgreSQL, the open source version, and Postgres Advanced Server. The only thing that does not work with PostgreSQL is the performance diagnostics. Currently, those are only available for EDB Postgres Advanced Server.
Okay. Another question that came in actually a couple of times, people want to know if there's an equivalent to automatic workload repository reporting in PEM.
Not really. I mean, Shesh, I mean, we get that question quite a bit. There's a capability in EDB Postgres Advanced Server called Drita, which is dynamic runtime something, and that comes closest to Amazon's AWR. Or Shesh, what would you recommend to a customer when they're asking about an equivalent to AWR?
To be honest, I don't have the answer for that because there is no direct capability. We need that capability in the database servers to make it available in PEM.
Yeah.
Because PEM relies on those capabilities, to be honest.
So my answer would be, take a look at Drita. That should give you the closest answer to AWR to tell you what workloads have been running on the server at what point in time. Or Bruce, do you have a different idea how we could provide that equivalent?
Yeah, we get this question asked quite a bit. The basic problem is that you're not going to get one-on-one comparison between other databases and Postgres, particularly at the administrative level. Postgres is going to have stuff that you need to monitor that the other system didn't need, and there's going to be stuff the other databases needed to monitor that Postgres will be like, there's no need to monitor that, right? So I think at the application layer, we're very close to or exceed pretty much the capabilities of most other relational databases. The administration side, it's just a different experience because there is no SQL standard for administration or monitoring. So each database is going to produce its own, tools that are customized to what the needs are for that database. And of course, the needs of Postgres versus other databases is just different.
Okay, it looks like we have room for just one more question that came through. Someone wants to know, are there any advantages using pgadmin along with PEM, or is it not needed based on the functionality available in PEM?
Shesh?
Yep, so PEM is actually extended version of pgadmin. We have, as you already know that some of us are on the community of pgadmin, we are utilizing the same functionality of pgadmin in PEM. We are extending PEM from it, and all the administration functionality is extended from pgadmin. So you really don't need pgadmin when you have PEM. Only place you might need pgadmin where you have a continuously containerized environment. But again, you can still utilize PEM to do the same job.
Yeah, I mean, just to illustrate that, pgadmin is at the core of PEM, just like PostgreSQL is at the core of Advanced Server. And just recently, for example, PEM has become WCAG compliant, right, or Section 508 as it's often called in the US. And the way we did that is we started with pgadmin because that provides the framework and the underlying technology to make sure that that was compliant with the needs for people who need, special support for working on screens. And then once we had that in place, we could extend that capability to PEM. So pgadmin is available inside PEM. It's one of the functions, and I don't think we take anything away from pgadmin.
That's
okay,
correct.
Great. So I apologize, that's all the time we have for questions today, but as a reminder, we had a bunch of great questions, so we will have those on the website on this webinar page. after the fact. Thank you all for joining us. We'll be sharing the recording along with the slides with all of you as soon as possible. And I hope you have a great rest of your day. Thanks.
Thank you. Have a nice day.